This is one last practice test to get you ready for the retake. This is very similar to the test that you took, very similar to the other practice test, but just we'll run through it one more time and make sure we're ready to go. So remember, make sure you show your work in thinking. Remind yourself we've got to simplify then solve. If you want to write yourself a couple little clues up on the top or off to the side, that's totally okay. Let's go ahead and do these problems. So remember, this is the variable term. We want to isolate that. So that means we want to get rid of the 6. We're going to do that by subtracting 6. So when we do that, those cancel each other out. They make a 0. And then on this side, we get an x over 4. And then we have a negative 3 minus 6. That's going to be a negative 9. And now we need to undo dividing by 4. So we're going to multiply both sides by 4. Notice the set of parentheses to show that multiplication. Those are going to cancel. So we get x on this side, and then a negative 9 times 4 is a negative 36. So we'll go ahead and circle that. This one right here, again, regular old two-step equation. Here's the variable term. If you want to circle that, that would be awesome. I'm going to go ahead and add 9 to both sides. Those are going to cancel each other out and make a 0, so the only thing left on this side is a negative 2x. Negative 5 plus 9 is a positive 4. And then we're going to divide, because remember, they're different signs, so we find the difference between those, give it the sign of the larger one. And then we're going to divide by negative 2. Getting ahead of myself there. Those are going to cancel off to be a positive 1, which is what we want. We want a 1 in front of the x, which we don't need to write. It's just understood to be there. And then we've got a positive 4 divided by a negative 2. The answer on that one's negative 2. Then taking a look at the next one, very similar format on this one. We've just got the variable over on this side. So this is the variable term. If you need to circle that, go right ahead. We're going to get rid of subtracting 4. We're going to do that by adding 4 to both sides. Those will cancel off to be a 0. That leaves our variable term over on this side, so we've isolated that. And then over here we get a 6. We're going to divide by 2 on both sides, so we get an n equals 3. Again, those cancel. That leaves a 1n, and then 6 divided by 2 is 3. Circle our answer so everybody knows we know what we're doing. And then again, this is that long fraction bar. Remember that long fraction bar, it groups these together. It groups the m minus 3 together. So we're going to keep those together. We're going to get rid of what that bar means. That bar means divide, so divide by 6. We want to undo dividing by 6 by multiplying by 6. So we're going to multiply both sides by 6, so we get an m minus 3 on this side, and we get a, let's see, 9 times 6 is 54, so pretty big number there. And then we want to get the m by itself just by adding 3. We get rid of that subtracting 3. So we get an m on this side, and we get a 57 on the other side. Again, these go pretty quickly once we've got these figured out. We'll take a look at this one. We're going to isolate the 4p, the negative 4p. Make sure you keep track of that negative. We're going to get rid of the 5 because that's assumed to be a positive 5. So we're going to subtract 5 from both sides. So those will cancel off to be a 0. Don't forget to write the negative in front of the 4. And then we get negative 31 minus 5. That's going to be negative 36. And then that, again, is multiplication. When we write negative 4p, we mean negative 4 times p. So we're going to undo the multiplication with division. So we're going to divide both sides by negative 4, and we end up with a negative divided by a negative is a positive. So we end up with a 9 right there. And then this one has variables on both sides, so there's not really any simplifying to do. We start solving this, but remember, we can't combine these. You wouldn't put the two of those together until we get them on the same side. Now, it doesn't really matter which one we move, but it's better to move the smallest one because then we work with fewer negatives. So we're going to get rid of the 4a by subtracting 4a from both sides. Those are going to cancel. We get a negative 3 over here. And look at this. 5a minus 4a is just 1a, or just an a, minus 18, and then we'll move the 18 to the other side. We'll do that by adding 18. So we get an a over here, and we get 15 on this other side. These have different signs. We find the difference between the numbers, and then we keep the sign of the larger one. Taking a look at number 7, you'll notice we've got the same thing. We've got variables on both sides. There's no simplifying to do, but we've got to make sure we get them on the same side. So if you had a choice between moving a negative 1n and a negative 5n, negative 5n is actually smaller because it's more negative. It's further to the left on the number line. So we're going to add 5n here and add 5n here. And notice what happens. Those cancel each other out to be a 0, so the only thing left on this side is a 4. And then we have negative 1n plus 5n. That's going to be 4n. And notice that we've got a positive coefficient. We like it when we've got positive coefficients because we tend to make fewer mistakes. In fact, in this problem, everything is positive right now, so we'll make fewer mistakes here. So we're going to get rid of the 16 by subtracting 16. We're left with a 4n over here. Again, these have different signs, so we find the difference. The difference is 12. The bigger one's negative. So we're going to divide by 4. and we end up with n equals -3. So there's our answer on that one. All right, let's take a look at this one. Similar situation here. There's no simplifying to do on either side, but we do want to move the variable. So I've got a choice between a 5k and a -4k. The -4k is the smallest, so we're going to add 4k to both sides. 4k to both sides. Those are going to cancel. -7 here. We've got a -7 plus 5k plus 4k is 9k. And then we've got to isolate this variable term right here. So I'll go ahead and circle that. If that's helpful for you, you're welcome to do that. I'm going to get rid of the subtract 7 by adding 7. So we get a 9k equals 0. And again, there's no problem having a 0 there because we're just going to go ahead and divide by 9. And it's totally okay to take 0 and divide it by a number. What's not okay is to flip that upside down. You can't take a number and divide by 0. But if you take 0 and divide it into 9 pieces, you still have 0. So let's flip this over and take a look at the other side. And here's what we've got on the other side. So we've got a variable term over here and a variable term right there, and then we've got a constant right here. Now, in this case, we would move the smallest one. We are going to move the -5v, but for more than one reason than it's the smallest one. The only constant is sitting right here. So if there's only one constant in the problem, you might as well move all the variables to the other side. So no matter what this one was, we would be moving it to the other side. And to do that, we're going to do the opposite of what we've got here. We're going to do the additive inverse, it's called. So we're going to add 5v here, and we're going to add 5v here. Those will cancel. That'll leave a -3, and then -2v plus 5v is 3v, and then we're going to divide both sides by 3. So those are going to cancel, and we end up with a -1 right there. Goes pretty quickly. Now on this one, we're back to doing a little bit of distributing. So we're going to distribute to simplify that side. That's a 5y plus 15, and then on this side, we're going to have, what have we got here? A -10. And then we're going to isolate this variable term by moving the 15. So we're going to subtract 15 from both sides. So we've got a 5y, and these have the same sign, so we're going to find the sum of those. So this would be -10 minus 15. That's going to be -25. We're going to divide both sides by 5, so we end up with y equals -5 here. And again, notice how much of this relies on being really fluent with the rules, how we do inverse operations, how we undo things, and then also how quickly we need to be able to do integer operations, how quickly we need to combine those, how quickly we need to be able to divide them, and so forth. So again, we've got some distributing to do here. So I've got a 72 here. We've got a 32 here, and when we distribute through, we get a -40x. There's the variable term right here, so we're going to get rid of the 32 by subtracting 32. And luckily this works out pretty nicely. 72 minus 32 is 40, and then over on this side we've got -40x. That's a multiplication problem right there, so we're going to undo that by dividing by -40. Those are going to cancel, so we get an x on this side, and we've got a positive divided by a negative, so that's a negative, and 40 divided by 40 is 1, so we've got a -1 there. Again, a little more distributing here. So 44, -4, plus 24m. We're going to move the -4 by adding 4. So this is 48, 24m. We're going to get rid of the 24 by dividing by 24 because that's multiplication we're undoing there. So we get an m equals 2. And let's go on, and we've got these last two and then just a couple more word-based problems. We're going to distribute -25x. Negative times negative is positive. Don't mess that up. We'd get the answer wrong if we did that. So we've simplified that side. Now we've got the other side. It's also simplified. And now we've got a variable on both sides. So we've got a choice between moving the, let's see, we can either move the -25x or we can move the 5x. This one's a little smaller, quite a bit smaller. So let's go ahead and move that one. So we'll add 25x. Those are going to cancel. 25 on this side. 5x plus 25x is 30x. Minus 5, so we'll add 5 to both sides. We get 30x over here, and lo and behold, we get 30 on that side. So the only thing we need to do to finish this off, again, we're interested in being able to show the work to support what the answer is. The answer on this one is x equals 1. And again, if you wrote x equals 1 like this, that would be okay. Probably better not to flip variables back and forth or switch sides of an equation. That's kind of a bad habit to get into in the long run. All right, let's go ahead and distribute. -12x. Minus 21, 19 minus 8x. Got both sides simplified. Now we've got a variable on both sides. So we're either going to move the -12x or the -8x. This would be the smarter one to move. Again, it doesn't technically matter, but it's going to leave fewer negatives for us to work with. So we've got a 19 here, and then put those together, we get a plus 4x. Again, notice the positive coefficient. And then we're going to subtract 19. Those cancel each other out because they're same number but opposite signs. So we get a 4x over here. Same sign, find the sum. We're going to add 21 and 19 together. That's going to be 40, but it's negative because they're both negative. And then we're going to divide by 4. So we end up with negative 10 equals x. Circle that answer and we're all set to go. Okay, now on these last couple, this just kind of reviews a lot of the basic skills that we talked about, and then a little bit of some story problems or equations in context. It says, give an example of an equation that has a variable, a coefficient, and a constant, and label of which is which. Now, an equation has to have an equal sign. So I'm just going to write this. 3x plus 5 equals 9. We'll write that. And then the variable is right here. Okay, a variable is a letter that's used to represent an unknown number. And then a coefficient is the number in front of the variable, so I'm going to say that's the coefficient. And then constants, we've actually got 2 of them. Constants are plain old numbers, so since those are both plain old numbers, those are constants. And again, the reason this is not a constant is because it's a factor in front of the variable. It's the number sitting in front of the variable. Okay, now, on these last 2, here's what we want to do. We want to write an equation that represents what happened in the situation. So a couple of these are easy. They're not going to be difficult to figure out what the answer is, but we want to make sure that we have an equation that represents what happened. So on this first one, it said you had $9 before you paid for a candy bar and $7 after. How much was the candy bar? So the first thing we talked about doing is let's write C equals, and then I'm going to do $ candy bar. Okay, that represents how much the candy bar costs. So think about it this. We walked into the store, we paid for a candy bar, we walked out with less money. So we had $9 to begin with, and when we paid for the candy bar, we paid this many dollars for the candy bar. We paid C for the candy bar, and we ended up with $7. This equation represents what happened in the problem. So this right here is going to be worth like half the points. If this is a 10-point problem, you're going to get at least 5 of the points just for doing that. Now let's go ahead and solve this. Now I know you know the answer is 2, but let's just verify mathematically and algebraically that the answer is 2. So let's go ahead and solve this. So I'm going to subtract 9 from both sides. So I get a negative C over here, don't forget that, and then 7 minus 9 is negative 2. Remember, we can't have a negative in front of the variable, so there are 2 things we can do. We can just say, hey, I don't want negative C, I want positive C. So that would be C equals, and then I don't want negative 2, I want positive 2. Or we could just go through and divide everything by a negative 1. And this right here would be the answer. Now, we're not finished until we write the answer as kind of a sentence. So we're going to say $2 for the candy bar. Okay, $2 for the candy bar. Now, if we had gone in and we had bought 3 candy bars or something like that, we might have ended up with an equation that looks like this. So I'll change the numbers a little bit. Let's say we had $20 going in, we bought 3 candy bars, and we walked out with $11. So we do minus 3 times the number of candy bars, and we walked out with $11. And then you could solve the problem that way. Okay, but that wasn't the problem. It was a much simpler one, just like this. Now this last one, it says you bought some pens for $2 each and then a $5 magazine for a total of $19. How many pens did you buy? So I'm going to say P for pens, and I'm going to put a number sign there because we're talking about the number of pens that we bought. We're not talking about how much they cost because they told us they were $2 each. We're talking about how many pens we bought. So $2 for every one of the pens. So 2 times P would represent the amount of money we spent on the pens, $5 magazine, and altogether the total was $19. Again, if you can do this, that's half the points right there. And then we've got a relatively easy 2-step equation to solve. So I'm going to go ahead and subtract 5 from both sides. So this is going to be 2P equals, that's going to be 14, divide by 2. And somebody must have been pretty happy about those pens, or they must have been a good deal because they bought 7 of them. So they bought 7 pens. We'll circle that and we're done. Okay, if you can do those problems, you've got this figured out. We're going to have a retake on this. Please make sure you study hard. If you need to watch the video again, if you need to do more practice worksheets, please grab whatever you need. This really does pay off. We're going to be using these skills over and over and over again. If you're in 7th grade right now, you're probably going to be using these for at least the next 6 or 7 years. And not only that, maybe 20 or 30 years from now, you're sitting around the dinner table helping your own kids with these, maybe even grandkids someday, because this is not going to change and solving equations is not going to go away. All right, good luck preparing for the test.